So this will do everything itself, right?
Yeah.
Yep.
Or we have to make some changes. So can we control the deposition time as well? It's like if we, right now we are doing 100 cycles, right?
Yeah.
So 100 cycle, let's say, 100 cycle will give how much thickness? Any guess?
It should be around 10 nanometers.
Around what?
10 nanometers?
Yeah.
10
10 nanometers.
It's going to be
Okay.
hard to visualize it.
So if we do 50 cycle, it will give 5 nanometers. Okay. And 10 nanometer takes 1 hour. 5 nanometer will take half an hour.
Where? Okay, so is the process started now, you think?
In 45 seconds.
Oh, in 45 seconds. Okay.
Yeah.
So what is it doing right now? As it's
Right now it's purging the system and purging the chamber.
it's purging the system and purging the
Yeah.
chamber.
Because when every time you load the sample, you're exposing it to the atmosphere, so you
Right.
want to purge it again.
Okay.
Yeah.
And that purge time is already is automatically set. The how long it?
Yeah, for the custom recipes and the load recipes, it's set to 10 minutes, but
Okay.
I would increase the purge time at the beginning if you're using a heated source.
Okay. Okay.
Yeah. And it might be a little bit longer too. Oh, you can see it starting.
Oh yeah.
Yeah. So you see it pulse 3, and now it's purging, and then it will pulse 2 of the water, and then purge.
Okay.
So 1, 2, and then it will purge.
Okay.
And you can see that the pressure is rising, so you know that it's actually getting dosed. During
Okay.
the process, we have it. We also have a setting that I believe it's happening right now. Is there's a setting in the setup page that is flow during purge. And so in this process, for example, you're flowing more nitrogen during each purge.
Okay.
Yeah. For TMA though, that's not super specific. So you could run this process without that setting on. But for now, it's fine.
Okay.
I think it would yield the same result.
So like now TMA is
So in the
going.
pressure curves, we should be
here.
able to see it, right? No. Okay. So we have in the
Yep.
pressure curves, we have every time we introduce the. So that's one cycle of TMA, second cycle. 1, 2.
So let's say how many materials we can do from this ALD, Al2O3, hafnium oxide,
Platinum.
platinum. Okay.
And that's it. For now, right now, we have only 3 precursors.
Al2O3 and platinum.
So these peaks have reduced here for whatever reason. Compared to these.
So this shows pressure, right? Pressure in the chamber.
Yeah. Is there a reason why that may be happening? The peaks here do not correlate with these peaks over there.
Those peaks are probably the water. The water pulse can be large, and if it's the first time, or like if you're first starting to use the water pulse, then there's probably like some air still trapped in that like line,
Oh,
because since the water doesn't have like a valve on it, you just like connect it directly.
oh, water doesn't have a valve on it?
No.
Okay, okay. That's what I was wondering because I did not turn on any valve on the water. Just wanted to make sure.
So if
Okay.
you pulse that line for the water, it will always just dose into the chamber.
Okay. So this is okay. This is expected. Okay.
Yep.
Because here we are no longer seeing those.
Well, since the purge flow is higher than like the standby flow, it will increase the pressure during that purge flow time, which is why it's like all level at the top.
Yeah, so now we are not able to see those peaks anymore. It's just maybe few peaks.
I was like, why?
Let's monitor the pressure here.
Yep. Well, because it's at 55 skim right now, and then it goes back down to 25 skim when you're pulsing it in.
So after every TMA, you are doing 55 SCM of nitrogen first,
Correct.
and then we're doing the water,
Yeah.
and basically the 25 SCM of water nitrogen is just as the carrier gas to get the.
Yeah. For this process, you can have it so then the purge flow is the same as the standby flow. Just like the setting it's set up in right now in the setup page has it so then during purge it's 55, not 25.
On the setup page.
Yeah. So you'll see the adjusted flow during purge right now is set to 55. For this process, though, it shouldn't matter.
So the standby flow is right now 25, right, for our process?
Yeah.
The standard flow, okay, but
anything between like 10 and 20, like anything between 10 and 40 is fine.
Okay. Okay, so while this is running, can you also talk about for example, platinum deposition?
Yeah, so the platinum deposition is definitely a little trickier. I assume you're trying to deposit platinum metal, not platinum oxide.
Yes, platinum metal.
So for the platinum, I can help you set up a starter recipe in the custom recipe screen for that if you wanted to try that later today.
Okay. So we go to custom recipe.
Yep. And so the recipe I have here is we'll put it in custom too. The deposition temperature is 250.
270.
270 or
and then
250?
you're gonna
250. Right?
250. Yeah, that's good. That's good.
250.
And then you're gonna click yes for static exposure, and then do 1 second. No, in the other one. Yeah.
Okay.
And then for the A pole, so for precursor A, you'll select platinum, and then you're gonna do 4 pulses.
4.
Pulses over there.
And then the purge will be 25 seconds.
25.
Oh wait, that's minutes.
Oh, sorry.
Some of the boxes are, it's confusing because some boxes are seconds and different ones. And then so for precursor B, this is where you're gonna select the ozone.
Oh, ozone. Okay.
And then you can leave the no and no.
So what does this mean, aux on? What is this?
So aux on and aux off is, do you have the ozone connected to the ALD to the ALD tool, like through the not like in the valve, but through the power connector?
So we have the ozone generator here.
Yes. Show me the other side. Yeah. So you have, okay. So you see in the bottom right, that connector there?
This one?
Yeah. So that one is going to the back of your tool, right?
Yep.
And so basically this connector communicates with the tool. If you go into, so now we're gonna go back to the tool. And then
The actual tool.
go to the main screen. And then you see the logo in the top left. And then do you see the little, the top left?
Top left.
And then do you see the little numbers, the 410?
Yeah.
Like
410
the software, you're
yeah.
gonna hold down there. Yeah. And then this will take you into the factory setup. And so the password for this is factory. And then okay.
Okay.
And so here you see on the left side where it says AT Ozone installed. You're gonna click on.
Okay.
And then we can exit that screen.
So everything else is fine. Okay.
And then in the custom recipe screen, let's go back to that. If you were to click yes on the ozone for the precursor B.
Yeah. Here?
So the way that the ozone works is that it's always, so you turn it on and then the ozone cell turns on like the little screen. And then the only way for the screen to turn on is for it to be set to ozone. So if it's set to oxygen, the screen's not going to turn on. You'll only hear the fans. So you'll have to switch it to ozone, but the power output on the actual like cell will read, I think it starts up at 0 power output. So if you don't want to be flowing ozone, then the power output will be 0. But then if you're running this recipe, you're going to want to set the power output to 100. And there's like a little power bar on the bottom that we'll show you. And then, so this aux on for the O3, you click yes. And so if you're running a recipe with ozone, for example, and you don't want it constantly like creating that ozone to be pulsed in from the back, this will tell the ozone to turn on and off basically in between each of your pulses.
Okay.
Does that make sense? As opposed to just like having it on.
Okay, let's get to the beginning again. Sorry. So you have custom 2, we have platinum.
Yep.
Precursor B is ozone. The reason we are able to do the ozone is because we have the ozone generator in the first place, right?
Correct.
Okay.
Yep.
Or we would have done oxygen. If you did not have the ozone, we would have done the oxygen, yeah?
Yeah.
Okay. So I chose ozone and then O3 aux on. Yes. Why do we have two of these buttons here?
The aux on, so the yes that you currently have clicked is matched with the O3 aux on.
Okay.
And the other one on the right, the no that is not clicked yet, is the H2O and ozone like pulsing at the same time.
I see.
Basically.
I see. So it's either or, right? You either have that or
it's either or they're both no.
Or both no, right. Right. Okay. So
the reason why it's yes for this, well, it can be no, but if you're putting it on yes, you're telling the ozone generator to only turn on when a pulse is happening.
Okay.
As opposed to it always being on.
Gotcha.
Which would be no.
So when I did no, what does that mean? That means it's always on?
If it's no, that means the ozone generator, it's like constantly, like the power output is always 100. Ready for it to like pulse into the ozone line.
Okay. So that should be on then.
Yeah.
That should be on. I mean that should be yes. So no means the ozone is basically at 100% on.
Okay.
And it's continuously producing ozone.
Okay.
Now when I say yes,
it's continuously producing it, but it will only get pulsed in when it is ready for that ozone pulse.
Right. Okay. So when I say yes, it's only powering on when it has to purge.
Yeah.
Correct.
Yeah.
So why is it designed that way? Like I'm kind of confused. As in, from my understanding, when I say no, that means it's
For example, if you are running this platinum process and you're running it overnight,
Uh-huh.
which means your ozone generator is on overnight,
Right.
right?
Right.
If you have no on, the ozone generator will continue to generate ozone if clicked no, because you have it set to like it's always going to be flowing if you're flowing oxygen into the generator
Right.
to
Right. I see.
create more ozone.
Okay, and
But if
if
you
you
have
do
it set on
yes,
yes,
okay,
if you have it on yes over and you run it overnight, the process finishes in the middle of the night, it will turn off the ozone.
I see.
So it's no longer generating any.
hmm,
Okay.
hmm.
We designed the ozone so that it goes into a destruct after, so safety wise it should be fine. And by the time it reaches the exhaust, it's probably turned into oxygen anyway, but it's just a safety feature.
So what you recommend? Yes or no?
I usually just use no,
Okay.
Okay.
but if you're trying to like we also have just like an oxygen generator that goes straight into the ozone, so we're not like just drawing it constantly from a cylinder. So, but
Okay. So right now I'm having it at yes, so that
yeah, that's fine.
once the system is done
Hmm.
depositing, it will automatically turn off.
Yeah.
Well, it's not on right now.
Sorry?
It's not on right now.
It's not on right now. Yeah. But
Yeah.
once we run the system, it's going to. So we need to manually turn this on when I'm running the system, when I'm trying to run the cycle.
If you're running with the ozone, you have to turn on. Yeah, you're gonna have to turn on the ozone generator.
Okay, manually.
Manually?
Yeah, we can turn it on right now.
Okay. And when it turn on, it just towards the ozone side, right? I see like O2 and ozone. So
Correct.
manually towards that side.
What's
You
that?
see that
The
button?
generator,
Yeah.
the whole thing
Yeah.
will turn
This one,
on.
this
You'll hear
knob.
the fan turn on, but then the screen will only turn on if it's on ozone.
Okay.
Let's finish out the rest of the recipe.
Okay.
The number of B pulses will be 2. And then
Okay.
the purge time will be 30 seconds. Yeah. And then
That's the number.
flat,
Yeah.
we've seen a pretty low growth rate. I don't know how thick you're trying to go, but we've seen like 0.4, 0.5 angstroms per cycle. It's a slower process.
So
Yeah.
is that a continuous film? Do you get like that's the compressor. So that was the air compressor that turned on. And then so yeah, is it a continuous film or does it start off as isolated particles and then how does it work with platinum? I never.
I don't know a ton about it, but I can ask my colleague who's been working very closely with it.
Okay. Okay, so 0.4 to 0.5 angstroms per second. So
Per cycle. So it's like if we give 100 cycle, it will become like
4 nanometers.
50 angstrom is like 5 to 4 to 5
Yeah.
nanometer. That's really small.
Yeah.
Yeah. And total time it takes like 1 hour.
The platinum will take a lot longer if you're trying to grow thicker films, just
Yeah.
because you have to purge for just so much longer.
Mm-hmm.
Same with hafnia though too.
So what about hafnium? Okay, so now we are done with the recipe, right? As in.
Yep.
Yes.
You can just put in
Maybe we can put 100
You
cycles
can
for
just
now.
stick in a number,
Yeah.
Okay, so, and then
Set file name.
Oh no.
okay.
You only set the file name when you're gonna run the recipe.
Okay.
Yeah. By setting the if you run the same exact alumina recipe after this run, you'll still have to name it.
I see. Okay.
Yeah.
Now can we save this in the load recipe now?
I don't know if a platinum recipe is already in the saved.
Okay, maybe we can do that. So this is,
load recipe.
yeah. So this
Yeah,
is the
so load
time
will
that is
be
still
50.
left, 34 minutes. Okay.
Yep.
Okay, load recipe.
Yep, and there's already a platinum recipe in there.
So we got DB fill, DB close. So this is slightly different than what we had in the custom recipe, right?
No, so the custom recipe, it uses these same values.
Okay.
Because okay, so you see the DV fill, the DV close, and the valve. You
Uh-huh.
see those values?
Uh-huh.
Those are the same values that are in the setup page.
Oh, okay. I see.
You can change them here in this recipe, but for those recipes, they're the same as the setup page. And
Okay.
so, for example, in the custom recipe that's happening, it's pulling those same values from the setup page.
Okay. So I have A pulses. So let's actually try to add one recipe. Why don't we actually do one thing? Why don't we add a platinum recipe that we just put there?
Yeah, I think it's slightly different too. So
Yeah. So let's do that. So maybe I can add
a note that you should note here in this load page, all the times are in milliseconds.
milliseconds. Okay.
Yeah. So that's why the purges are like in orders of thousands.
Okay. So so now we have add row. Should I click add row?
No, you don't need to do that because you have a bunch of recipes like open. So all you need to do is click edit on in the
Okay.
top right, and then click the field you want to change. So under fixed recipe name, click just like that empty area in 3.
Okay. I see.
Yeah.
Oops.
And then it will fill in that field.
Okay. So let's say this is what do we name this?
Platinum.
Let's
It can
let's
just
actually do.
Let's say
yeah,
platinum.
platinum 250 degrees. Yeah.
Degrees.
I think the other
Should we write like number of cycles or can we write like thickness?
you don't need to do number of cycles or thickness because you'll fill like for these recipes you're only setting the recipe, never the number of cycles.
Okay.
So you can kind of see it on the bottom, in the way bottom of the screen, it says recipe number. That's where you're gonna like call the recipe number that you want, and then you'll just input the number of cycles for like the recipe you're using.
Okay. So okay, we got that.
Yep. So the DV fill should always be 1,000.
1,000. What is the DV fill? What does that mean?
That's the dose valve fill. So it's filling for 1 second. So it's pulsing from the bottle to the dose valve, and it's taking 1 second.
Okay, and this is DV close is 650.
Yeah. 650, yeah. So all those values should be the same.
And these are the same values that are on the setup
In
page.
the setup.
Okay.
Correct.
And
You
that's
can
like-
experiment with different values, but the default works pretty well.
Okay.
Um,
So exposure A, exposure B, per
so
millisecond.
Expo A is for precursor A, I believe. So you'd put in 1,000.
Thousand.
And then
How come we don't have any of that in the other ones, other recipes? Like
because for most of the recipes you don't need exposure unless you're trying to do higher density or
Gotcha.
like high aspect ratio.
Okay. Exposure. Okay.
For Expo B, that's for water, so you don't usually put in, or for ozone, you don't usually put anything in field B.
So can you say a few words about exposure again? I'm just taking a note of it for future reference.
So the exposure is when you want to have like a higher aspect ratio or penetrate deeper into the film. And so what it does is it not traps, it keeps the precursor longer in the chamber exposed to the surface before purging it.
Okay. So it has time to diffuse through the thickness.
Correct. So depending on what you're trying to do, you might use it, you might not. Or you can experiment with it as well.
Okay. So keep the precursor longer in the chamber. Okay, I see.
Yeah.
And so for a flat film, you don't really need, for a flat film, you don't really need that, right? Exposure B is
Nope.
water, so we don't need that.
Nope.
Step
Or
temperature.
for this, it will be ozone, but you still don't need it.
Yeah.
Step temperature 250.
Okay. That means I can only
Oh,
do high temperature substrates for this one, this recipe.
Correct, because if you run recipe 3 right now, it will always be 250.
Right. Okay. A pulses, B pulses.
Yep. So I believe it was 4 and 2, 4 and 3, 4 and 2.
4 and 2,
Yeah.
okay. A pulses is 4. B pulses is 2. Okay.
The scroll's a little funny, so you might need to scroll on the bar, or you might need to.
Yeah.
Oh, there you go. Nice.
And A purge.
So purge A will be 25,000.
So that's 25 milliseconds, yeah?
Yeah, 25,000 milliseconds, so 25.
Oh, I'm sorry, yeah, 25 seconds, as in 25 seconds.
Yeah.
And then B
And
purge
then purge
was,
B will be 30,000. Yep.
30,000 milliseconds,
And then
okay.
the manifold temperature will be 110.
110.
That will be 105 still. Oh, and then here you can set the precursor temperature. For this recipe I have that the platinum source will be at 82.
82. Okay.
Yeah. Oh, you can probably that in recipe 2, that's a platinum one too. I would put 82 as well for recipe 2 precursor temperature, because I saw that was a platinum as well.
Okay. So,
And then
but
you're
how
gonna
does
click
it
Expo on
Expo?
for recipe 3, right? And then ozone.
Yeah, ozone on, right?
Yep. And then you can click edit off on the top.
So, my question is, what is precursor temperature, right? Okay, so it doesn't treat water as a precursor here.
Correct. It's only talking about the metal sources.
Okay. So if I want to run on a single recipe, if I want to run 2 precursors
Yes.
alternatingly, how do I do that?
Then you would do that through the multi-layer screen.
Come again?
Then you would do that through the multi-layer screen.
Multi-layer screen. Oh, okay. Multi-layer screen. Okay.
Yeah.
So edit off.
Yep. So now you can just scroll freely in it without it like pulling up the edit boxes.
Yeah. Okay, so that should be done, right?
Yep.
So that is set. Okay.
And then once you want to run that recipe, on the bottom, you'll just put recipe number 3 because it's row 3.
Recipe
And then the
number 3 and
number
then run. Okay. So let's see if you exit this. You got 26 more minutes for that. Okay.
Yep. If you wanted to run the platinum today, I would go into the heater screen right now and start warming up that source.
To the heater screen?
Yep.
Oh, and
then platinum,
it's 80
put
degrees
it to 82.
82. Okay.
And then on.
Okay.
Yeah, to just start heating up if you're trying to run that today. Oh. Nice. Okay. So let's look at the ozone.
Okay.
So the ozone box on the top, you have it all connected and it's off right now, right?
It's off right now, yes. So when else do we need ozone? For what other recipes do we need ozone?
Definitely silica.
Silica?
Yeah.
For hafnium?
You can run hafnium with water. I believe I also have one with ozone. Let me check. I think you can run the hafnium with ozone. I don't have a recipe written down.
Okay.
But I can also get back to you with email about that.
No worries, no worries.
And you can also do the TMA with ozone too.
Okay, so what is the advantage of using ozone here?
I think depending on what you're trying to do, it can yield a higher quality film. But for TMA, the water is like pretty good.
Okay.
Wait, so is your ozone connected? Is it ready?
Yeah, it's ready. Should I turn it on?
Oh yeah, so you're gonna turn it on using the power switch underneath the power cord. That switch. Wherever the power cord is coming in, that switch.
Oh, the power cord. Okay. Can you check if the
That's the power.
huh?
That's powered.
It's powered?
Yeah, that's powered.
So you're gonna want to switch it on the power cord, and then also switch on the toggle. The red.
Oh,
the
there's a
red toggle.
toggle too. Oh, I see.
There's two.
Okay. Ozone.
Did the fan turn on? The fan is usually the first indicator of if the systems are on.
Turned on. I've toggled it to ozone.
Yep. And then the screen should turn on as well.
The screen is not on. The power switch is on.
And it's on. The fan's running.
No, the fan is not running. Oh, okay, I see. Now
Yes.
it's on.
There you go. Is it on now?
Yep. Now the fans are on.
Awesome. And then has the screen turned on yet? Sometimes it can take a
Screen is turned
second.
on, but the fan looks like a
Yep.
I know.
So you see the two dials?
It's on the screen now.
what's that? Okay,
On
I
the
can see the
screen.
screen.
You see the plus and minus button
On the screen or on the back side?
on the
Fan
screen.
is not turning on though.
Actually, you see, like the this wire is coming in.
Yeah. I think the
Like no, air is coming out.
there are maybe are there two fans because there is one fan where
There's two
the
fans.
what's that?
There's one on. There's two fans.
Okay.
You won't be able to see the other fan because it's
But are
internal,
are both the fans supposed to be on?
that fan is.
Is it on?
The
Is it spinning?
fins are not rotating.
The outer fan is not rotating, as you can see,
Mm.
Yes.
because looks like there are cables coming in the way of the.
Bring it close. Bring it close. Bring it close. Is the cable coming in the way? This
Yeah.
cable?
Right?
Is the cable coming? Will can you can help that?
Yeah, the cable looks like the cable is
That's
coming
right.
in the way of the fan.
Oh, there should be there.
You see that?
Yeah.
Should we try to adjust manually from outside from the fan?
You think we should push the cables inside to see if the fan turns on?
You could try. But I feel like it's strong enough.
Maybe it's supposed to be
Maybe
like
that is okay because it's just a design.
yeah, it's not turning it. So
Wait, and the red toggle. Oh wait, go back to the red toggle.
red
And
toggle.
you have it switched up. Switch it up. Switch it up.
It's on. It's up.
So the fan's still not turning on.
Yeah, there is one fan that is turned on, but not the exterior, the
Yeah,
outermost.
that one. Yeah.
Yeah, that's not turning on. It's actually almost looks
Okay.
like it's kind of it's not moving at all.
You might have to wait on the platinum then.
Okay,
So just turn off the ozone for now then.
turn off the ozone.
The outer fin.
So are both the fins supposed to rotate? Both the fans?
They should. I mean, either way, you should still feel air coming out, regardless of if it's.
Yeah, we could
One
feel the
fin.
air coming out, of course.
We feel the air, but like maybe like this is not a fan or this is just a design.
Maybe.
I
I don't know.
Let me look 1 second. Okay, yeah. So I have one right here.
Okay.
Yeah, so there's like the I don't know if you can see it, but
Oh, okay. I
this
see.
grill here, these
Yeah.
are stationary.
Oh, okay. Stationary. So
These are
That remains
stationary.
stationary.
Okay.
Yeah.
But then this one
That's
in
right.
the inside is
right. That's
moves.
running. That's running.
Yeah, that's running.
Okay.
Okay. That's good. That's good
Okay,
to
yeah,
know.
that's fine.
You want me to turn it on?
Oh, yeah, sure. You can turn it back on. And then you're going to want the input for this to be probably around like anywhere between like 15 to 20 psi. And you'll see the pressure output on the screen in the bottom right. On the, yeah.
No, that's not the one.
No, on the actual.
On
Yeah,
the
yeah.
top. Okay. Oh, I see. So what
The
is this
bottom right.
air one? The flow controller here on this system.
That's for the nitrogen.
No, this one. This one.
Oh, that's the pressure regulator. So you can also control the pressure using this knob, but for whatever source, like do you have oxygen flowing into that right now or no?
Yeah, it is flowing.
And then what's is the pressure reading on the screen though?
On the top. On the
It
top.
should read at least some pressure.
On the,
Do you mean on the top
on the top
screen or-
screen, you said?
On the yes, on that in the bottom right corner of the screen.
Yeah, over here on the top screen. Oh, yeah.
On the bottom right, there should be a pressure readout. It says zero. Oh, yeah, pressure. It says 0 though.
Yeah, that's, you know. Yeah.
Yeah, 0 psi. 0 psi.
Yeah. If you're turning on oxygen and it's flowing directly to it, it should give. There should be some sort of reading.
They're checking the oxygen line in the back.
Okay. And then once it shows the reading, then you can adjust it with the knob.
Okay.
Yeah. But anywhere between 15 to 20 on the ozone generator is fine.
Okay, 15 to 20, perfect.
Yeah.
Should the process be running right now? I forget it's supposed to be on. Okay, gotcha.
Once you run the recipe, it does its thing, and it's very automated.
I don't know what that was.
It is dropping.
Oh, okay.
Being released.
Air being released, yeah, through the valve. They're just a big popping noise, but now the ball in there it shot up and now it went back down.
Oh.
I guess let's see.
Anything?
No, still no pressure.
Do you hear any air? Like leaks? Like hissing?
Well, we did all of a sudden. There was a really loud popping sound, but now I'm not sure if there's air being released or not. Oh, now I hear something. Yeah,
Oh,
it's still at 0,
like
but
a hissing?
it's like kind of like a little popping sound. Maybe not like hissing, like here. No, yeah, there's no like hissing sound. Like if there's supposed to be just a regular hissing
Okay.
sound, there's nothing.
That's a good thing.
Okay, that's a good thing then. Okay.
So what happened
Yeah.
to?
Well, because the popping
Is it-
made me think that maybe like an
It
airline
gave
got
some
loose.
popping
Then
sound,
if
and
the
then
airline
this
was loose.
Yeah,
drop
that
to
would
the
make
bottom.
sense.
The air
Yeah, but if there's
that
no
dropped to
hissing,
the
that's good.
bottom.
If there's no hissing, that's fine.
Yeah, that means there's no air leaking.
Okay, good. So I think it's good, but there's still no pressure on the top. Is the dial on this
Sometimes the
On-
dial, you really have to crank it to get a reading. So maybe it's that. I would release the dial.
Can you show this?
You pull it
Right.
out and then you turn.
Like this one on the side here?
Yeah, the big plastic knob.
Oh, the big one. This one on the back?
Yeah.
Okay, so pull
So
it out and then left or right, like clockwise, counterclockwise?
Right.
Right, counterclockwise. Okay.
You really have to crank it sometimes to see a reading.
Okay.
That knob can be particular.
Yeah, it's still going. There's still no reading on the screen.
Mm. Interesting.
Yeah, I made it all the way to the right,
Oh.
and there's still no.
So once the film is done, we just
You
When-
just vent it, and then you can. The fastest way to know if there's film, either I don't know if the 100 cycles you'll see anything on the back of the wafer, but usually we use ellipsometry
okay,
just
Okay.
for measurement.
okay.
Yep.
All right. So next week then?
Yeah, I can set up a meeting next week at the same time.
Okay, great. Thank you so much. Appreciate
Okay.
that.
See you next week.
Yeah. See you.
Okay. Bye bye.
Bye bye.